here's a diagram for this question where there's a block of mass 0.2 kgs and it's been compressed by 10 centimeters. So when something's compressed by 10 centimeters, its length is changed by 10 centimeters. Its length is changed by 10 centimeters. And 10 centimeters is how many meters? 0.1 meters. The block's then released, so it's compressed here and then it's released and it shoots out here, and it has a speed of v of 5 meters a second after it's been released. Right, what's the spring constant K of the spring? So we've got two formulas that have spring constant in them. F equals K change in X, and we've got spring potential energy equals a half K change in X squared. The using this one to find K, we don't know the force. We know change in X, so that's good, we've got that. We don't have the force, so we can't rearrange this one to work out K. If we want to use this one to work out K, we've got the change in X. We don't have the spring potential energy, but it turns out we can work it out. So when this is compressed, it has spring potential energy, and this turns into, after it's been let go, it turns into kinetic energy. And using this velocity here, we can work out the kinetic energy, use it to work out the spring potential energy, and use that to work out K. So that's what we're going to do. Let's just write what we're going to do. We're going to do kinetic energy, which is equal to the spring potential energy, which we're going to use to work out K. Because spring potential energy, this is compressed, is turned into kinetic energy. So let's do part 1, and we'll say kinetic energy is equal to a half mv squared, which is equal to a half times the mass of the block is 0.2, its velocity is 5, so that equals, doing a new calculator, 2.5 joules. It's part 1. Part 2. Therefore, the spring potential energy equals 2.5 joules. And the formula for spring potential energy we've got there, a half K change in X squared. So if we want to rearrange this to find K, divide both sides by a half, or times both sides by 2, so you get 5 equals K change in X squared. Divide by change in X squared, you get 5 over change in X squared equals K, and put the number in for change in X. Change in X, 10 centimeters, 0.1 meters. Make sure you get that 0.1. 5 divided by 0.1 squared equals K. You do that on your calculator, 0.1 squared becomes 500 newtons per meter. Alright, point C here. The block encounters a rough surface, this rough surface here, that provides a constant friction force, and it brings it to rest at point D here. The distance from C to D is 2 meters. Okay, we've got that. What's the magnitude of the friction force that brings it to rest? There's two ways we can work this one out. So I'm going to work them both out, and hopefully they will give us the same answer. So the first one is I'm going to use work. Now work, I like having a definition of work as the change in energy. Now in this case we had 2.5 joules of energy, kinetic energy here. Well, we had 2.5 joules of spring potential energy, got turned into 2.5 joules of kinetic energy. By the time it gets to here, it's completely stopped. No more kinetic energy. So where did that 2.5 joules go? Well, it went into this rough surface and it turned into heat energy. So 2.5 joules of kinetic energy gets lost. That's how much change in energy we've got. So the work equals 2.5 joules, and work equals force times distance. So 2.5 equals force times distance. The distance is 2, 2.5 equals force times 2. Rearrange that, you get F equals 1.25 newtons. That's Y1. Y2 is I want to find the force, and my favourite formula for force is force equals ma. I've got the mass, 0.2, so I've got that. I don't have the acceleration though. So I'm just going to leave that there, and I'll need to work out the acceleration. I know that it comes to a stop at the end, so its final velocity is 0. I know its initial velocity is 5. So it brings it to a rest. That's why V equals 0. 5. We want to find out A, and we know the distance is 2 meters. So this is an equation of motion, and the one I'm going to use is V equals U squared, V squared equals U squared plus 2AX. To find A, to put in this equation to get the force. So let's put everything in. 0 squared equals 5 squared plus 2A times 2. Negative 25. So that's what the 5 squared is. I put it over that side. Equals 4A. The 2 times 2 is 4. A equals negative 6.25. MS negative 2. It's negative because it's going backwards. The acceleration is going that way. It's slowing it down. Alright, the force. That force is therefore equal to ma equals the 0.2, same mass, times 6.25, which gives 1.25 newtons again. It was negative because it's heading in that direction, but they don't want the they just want the magnitude, they just want the size of it, so we'll just call it positive. Same answer, both cases.